Number 69 has you want to scale in an elevator. So, so for part A, well, let's figure out this person's force of gravity. It says that this person their mass is 53 kilograms. So by using F equals ma, if their mass is 53, the acceleration of gravity is 9.8. So 53 times 9.8 is 520 newtons. So that's what gravity pulls this person down at, is 520 newtons. Now part A says that they're going up at a constant speed. So that's if you're moving at a constant speed, that means that the forces are balanced. So the force of the scale has to be equal to 520. Now why is that? You might ask yourself why. Because if this was any smaller, if the forces are imbalanced, that means it accelerates. Just like when we were in class and you grab the scale on the skateboard, if there is an excess force on you, it makes you accelerate. So for part A, the scale is going to read 520 newtons. It's going to read that if you're moving at a constant velocity, or it's going to read that if you're stopped. Now part B, it says it slows while moving upward. So I'm going to move down here. I'm going to have my same guy standing on a scale. He still has that same weight. Now, it's slowing while moving upward. So it's moving up but slowing down. So that means that it's actually accelerating this way. And that acceleration is equal to 2.0, and they tell you it right there, meters per second squared. So you've got the force of the scale. Now, because it's accelerating down, that means that the force of the scale has to be smaller. The scale has to be smaller because in order for it to accelerate downwards, this has to win. So we don't know what it is. I'm assuming that's what it wants to know. What's the scale? Yeah, so question mark. I'm going to use F equals ma. Now, remember that it's the net force that we're going to use. So the net force so let's see here. Which way do I want to be positive? I guess because I've got this and this, they're both going down. So I'm going to say that positive is down in my case. So I'll take 520 minus F of S. The mass of my person is 53 kilograms, and the acceleration is 2. So we take 53 times 2, that's 106. 520 minus F of S. So you take 106 minus 520. You get negative F of F equals negative 414. So the force of the scale is 414 newtons. Well, probably with significant figures, it's 410. I got a little bit rambunctious there. Yeah, 4.1 times 10 to the 2 newtons. Part B. Now part C, what do we got? It speeds up while moving downwards. Okay, so my guy again, on my scale, it's speeding up while moving downwards, so it's accelerating this way again. And it's the same 2.0 meters per second squared. He still has the same weight. Force of gravity is equal to 520. So you know what? It's shaping up to be the exact same thing, and it is. The force of the scale is the same, 4.1 times 10 to the 2 newtons. Because you have the same acceleration, everything. This one you're slowing to a stop, and this one you're speeding up. So the you're only concerned with the acceleration. Part D says it's moving downward at a constant speed. Well, anytime you're moving at a constant speed, the scale is going to read the same thing. So the scale is going to read 520 newtons. And then part E, it slows to a stop while moving downward at a constant acceleration. Now this is tricky. This is a bummer because they don't tell you the acceleration. So I don't know what they're asking for as far as like an answer is concerned, but let's go like this. You still have your downward of 520 newtons. Now you're slowing to a, so that means your acceleration is in this direction. In this case, when you slow to a stop while moving downward, you're accelerating upwards. Now that means that the force of the scale has to be bigger, right? Because if you accelerate up, that means that there has to be an excess force in the up direction. So if I use my F equals my net, so I take, oh boy, which way do I want to be positive this case? Let's say positive is up in this case. So my net force is going to be the F of S minus 520. My mass again is 53. And the they don't give you the acceleration, so your acceleration is just A. So if you want to know what the force on the scale is, you just got to move the 520 over, so you get F of S. You get 53A plus 520. So they don't give you the acceleration, so you just kind of, it's the same as parts B and C, except in B and C they give you a number. Here they don't give us a number, so who cares? You just put it in as that, and you know, and life is good.